Jupiter, named after the Roman god king, is the biggest planet in our solar system, measuring more than double the other planets' combined size. From afar, Jupiter appears tranquil and lovely. But when you go near, you discover absolute mayhem. The planet's most famous spot is a massive storm that has been all the rage for hundreds of years. And this spot is so huge that it even dwarfs our own planet, Earth. Scientists created a 3D model of Jupiter's atmosphere using data from the Juno mission, which circles Jupiter. But what this series of 3D images has shown them is shocking. In today's video, we'll go over what the Juno spacecraft revealed and Elon Musk's collaboration with NASA on these Jupiter discoveries. So stay glued to the screen, you wouldn't want to miss this epic discovery. Jupiter is not just the biggest planet in the solar system. It also contains the most moons and the most powerful magnetic field that we know of. Astronomers have known about Jupiter for quite a while now, thanks to scientific devices used to study our universe, most notably the telescope and the advancements in modern astronomy, which have taught us a lot more about it. Several missions have been sent to Jupiter to explore the giant planet and its countless moons. The first ever mission was NASA's Galileo mission in 1989, and the mission's goal was to investigate Jupiter and its moons, which it did. Still, Galileo became famous for the discoveries it made along the way. Fast forward 2 decades, NASA initiated the Juno mission on August 5, 2011, and the Juno spacecraft was the one that was sent to Jupiter to investigate what lay underneath its thick clouds. Juno was launched into Jupiter's orbit on July 4, 2016, and the discoveries it has made so far have been both wonderful and disturbing. Although these were NASA-led direct trips to Jupiter, other spacecraft have had countless flybys, making Jupiter the most visited planet in the universe. Let it be known that it takes a lot of effort to send a spacecraft into Jupiter's orbit. Why? Well, the planet has a high radiation environment and a high fuel demand because of how far it is. However, in June, NASA revealed that it had selected SpaceX to launch its next alien hunting mission to Jupiter's moons. Europa, Jupiter's frozen moon, is the one in question. This is a huge accomplishment for SpaceX, since it implies they'll be able to travel further into the solar system like never before. The Europa Clipper project will take off from Florida's Kennedy Space Center in October 2024 and will be launched on a Falcon Heavy rocket, with a contract worth around $178 million. Most of us haven't made that much money in a lifetime. Scientists have created a 3D depiction of Jupiter's atmosphere using data acquired by Juno like we discussed before. But what did Juno find and how? These scientists harnessed microwave lights to peek deep beneath Jupiter's beautiful clouds. Using this technique, they can grasp the weather and climate in the planet's inner layers. Jupiter's satellite has also given us a comprehensive glimpse on how the planet's unique and colorful atmospheric characteristics provide information about its activities underneath its clouds. The flybys of Juno around Jupiter since 2016 have provided considerable data, such as the fact that most of Jupiter's lightning is located at its north pole. Juno also observed that storms near Jupiter's poles prefer to develop in symmetric clusters. There are also amazing auroras on the planet, which generate ultraviolet light that's undetectable to the naked eye. Juno's observations have also helped scientists determine why auroras develop in the first place. They occur when electrically charged atoms or ions travel through the planet's magnetic field before colliding with the atmosphere. The reason why this discovery is so exciting is because Mars has long been the most sought-after planet for other forms of life or a future home for us if Earth dies. But it appears that the moons in Jupiter's orbit, such as Ganymede, might possibly host life too. These frozen moons, including Europa, Ganymede, and Enceladus, are thought to have seas of water beneath their icy outer shells. What does that mean? Well, Ganymede in particular is a captivating and exciting astronomical target. It possesses a magnetic field that serves as a key protective barrier for living things. It's also important to note that Jupiter's most recognizable feature has always been the Great Red Spot. It's a 24,000 kilometer wide anticyclonic storm with a height of 12 to 14,000 kilometers. Because this storm is positioned south of Jupiter's equator, it has enough room to accommodate 2 to 3 planets with sizes comparable to Earth's. The huge red spot's position has been known since the 17th century, and it was discovered 350 years ago. Giovanni Cassini, an Italian astronomer, first identified the enormous red spot in 1665. According to astronomers, the turbulent and fast-moving atmosphere of Jupiter is the source of this storm. During Voyager 1's flyby of the planet in March 1979, the big red spot was seen up close for the very first time in the 20th century. The flyby validated these predictions. However, there were some observations such as the storm appearing to have shrunk. The size was estimated to be over 40,000 kilometers when it was originally discovered in the 17th century. According to Cassini's calculations, this storm has already shrunk to half its original size. Scientists are positive that the storm is weakening, but they aren't sure if it will totally dissipate, although they are certain that another one will take its place someplace else on the planet. There's no doubt that this red vortex has kept scientists on their toes ever since it was first discovered. But did you know that the storm is far larger than originally imagined, according to some new information? This storm conceals a dark, sinister secret. Hundreds of lesser storms blasted against the red spot but did little harm. It's as if they were to fuel the big storm. Is it possible that this storm is devouring weaker storms? Every year since 2019, the red spot has been hit by more than 24 minor storms, and NASA scientists have front-row seats to the activity thanks to Juno. The red spot suffers some surface damage from these smaller storms, but measurements from deep within the atmosphere reveal that the red spot acquires energy with each interaction. Juno has circled the huge red spot twice, probing for the storm's gravitational signature and investigating the air mass concentration within it. Using a NASA Deep Space Network monitoring antenna and a distance of more than 400 million miles, scientists were able to estimate a velocity difference as small as 0.01 millimeters per second. As a result of this, the team was able to limit the depth of the Great Red Spot to around 300 miles below the cloud tops as a result of this. According to Marzia Parasi, a Juno scientist at NASA, the amount of accuracy required to compute the huge red spot's gravity during the July 2019 encounter is absolutely mind-boggling. But we have high confidence that future studies on Jupiter will provide similarly exciting results, since we can incorporate microwave radiometer or MWR deep measurements. Jupiter's enormous red spot is only one of the planet's well-known atmospheric patterns. Another defining characteristic is the numerous bands of various color clouds. These colorful clouds are created by strong winds blowing in opposite directions to each belt. One of Juno's key mission objectives is to investigate this occurrence. In one of those missions, a specially built MWR will be carried by the spacecraft to monitor radiation from deep within the solar system's biggest planet. This equipment is even currently being used by NASA to investigate the nature of these belts and zones by diving deeper into the Jovian atmosphere than anybody has ever done before. The MWR can explore atmospheres at pressures ranging from 0.6 bars at the top of the atmosphere to more than 100 bars at depths of 250 kilometers. By following the ammonia, we uncovered circulation cells in both the north and south hemispheres that are identical to Ferrel cells, which govern much of Earth's climate. Jupiter contains 8 Ferrel cells per hemisphere, each of which is around 30 times bigger than ours. Karen Duo, the primary author of an article describing Jupiter's Ferrel-like cells published in the journal Science, explained this. According to Juno data, the belts and zones migrated 65 kilometers under Jupiter's watery clouds. Jupiter's belts radiate brighter in microwave light than the surrounding zones at shallow depths, according to NASA and the junk crew. The opposite is true at lesser depths, resembling our oceans. Microwave radiation from Jupiter's cloud tops illuminates the belt, while the zones remain black. Scientists believe that something in Jupiter is shifting as it gets deeper. They are not sure if it's the high ammonia levels or the cold temps. When NASA launches future missions to Jupiter, maybe more exact photos will be provided since Juno will have more time to study Jupiter's storms and other characteristics. As it continues its extended mission, which will run until 2025, it will have the opportunity to look at its neighboring moons. Fortunately, NASA may be able to prolong Juno's mission for another 16 years to keep learning more about this strange planet, its moons, and the Great Red Spot, all of which we've discussed today. And that's a wrap. Do you think there might be life in one of Jupiter's moons? Let us know in the comments down below. And thanks for watching.